Hey guys, welcome back to SaxSQL training. My name is Ferry, and in this video we're going to have a look at the nature of data. We need to make a distinction between what is called structured versus unstructured data before we can start to talk about how data is going to be stored in the database. So a quick recap, this is the third video in this series, like I said, and if you didn't see the first two videos, it's highly recommended that you're going to check them out first. The first video discussed what data is through the lens of a computer scientist, and in the second video we discussed the concept of what a database is, and particularly the place of a database as a repository to store data and access data by other applications in a modern day computer architecture, mostly called an information system, where an end user accesses an interface. The front end connects it with the back end, which is usually a server environment, which then contains a database environment that will be accessed by the server to technically decide what kind of information will be shown in what way to the end user to make decisions or to execute a task. So we will discuss the concept of data once again, but this time we're going to focus on a different aspect of data, not answering what is data, but technically specifically look at different kinds of data before we can technically make a decision what kind of data we can store in a database and what kind of data cannot be stored in a database and why that needs to be structured in a certain way. So I hope to see you on the other side. Welcome to SaxSQL.
Hi, this is Ferry, your data expert. Welcome to SaxSQL.
Okay guys, welcome to the third video in this series on databases. In this video we will address the difference between structured and unstructured data, which is important to identify which data can be stored in a database and which data should be stored and accessed in a different way. In the first video we already looked at what data is, at least through the lens of a computer scientist. Technically a quick recap of that is that data is everything you can put in a list. That includes all the written languages that are comprised of characters. Technically any symbol you can write down that represents a unique meaning in any language. And on top of that we also consider from a computer science perspective that anything that can be stored on a hard drive and is accessible by software, and in that case we mean pictures, video and audio files to be data as well. The computer can only store data in zeros and ones, in binary. So in that regard, the media files can all be considered to be data, as it can be represented by a string of zeros or ones, also called a binary string. A string is technically a term used for a sequence of symbols, so a binary string is a sequence of zeros or ones. Okay, so once we have that out of the way, I want to use a simple example to focus on what structured data mean and how that relates to storing data in a database. So let's return to the whiteboard and let me get that ready. So the whiteboard here is a bit sensitive, so bear with me, it will be a bit slower. So what we're going to do is we're going to technically use a real-world case study, which is in this case a simple game that we want to build, and we want to identify what data the game will store in order to make sure that the end user, the one that is playing the game, as we have discussed in video 2, will actually have to supply or to keep track of when playing a game. So the game we choose is Pac-Man, and the idea is that the application can keep track of the players themselves playing the game and also keep track of the highest score that the player has achieved while playing the game. So in that regard, the first thing we want to store is the name of the player. And of course, I can just write down name here. And this in itself is technically called a data attribute. That's the term we use as a computer scientist. A data attribute technically specifies the kind of data you want to store. Now, the second thing that we need, of course, is to keep track of the score of the player. So, for example, if I write score here, which is another data attribute, then we can first think about, okay, what are name and score actually meaning? So what we do here is we use something called a use case. That means we discuss the requirements of the game, and then we identify the need for these data items while we interact with the game. So if you play Pac-Man, then the first thing you are probably going to ask for is, what is your name? So you enter your name. So that means that the application need to be able to store and access the name of the player, which in my case is Ferry. Then the score, which is a numerical value that technically is stored next to my name in order to keep track of what kind of score I have achieved while playing the game. So for example, the first time I play, I achieve a score of 10. Now, 10 is of course a numerical value, as opposed to Ferry, which is a text value, or in computer science we call this a string value. So later more on strings and numerical values. That is the world of data types. So now when you look at this on the screen, then you notice a few things. The first thing you notice is that we have identified two rows. The first row here contains what is called the data attributes, the kind of data you want to store: a name of the player, and the score that the player has achieved. Now, in the second line, the second row technically, we have what we call data values. So Ferry is a name, of course, and a 10 is the related score to the name Ferry in this case. But of course, if you have a second player, let's say Bert is going to play a game as well, then let me just solve this problem with, hold on. Hey guys, interruption from the editing desk. I'm all new to this stuff, so I will glue this back together as we speak, and we will continue the video. Okay, something went wrong with the board, so I'm still getting the hang of it, but it doesn't matter. Let's continue. So as we can see, we have one player called Ferry with a score of 10, and if a second player plays this game, then we expect the software to be able to store the name and the score at that point in time of the second player as well. So let's assume that there is a second player called Bert that will be stored here, and his first game will result in a score of 20, so he did better than me. So the first thing you need to notice is we have two players with a different score at a different point in time. Now, when it comes to data storage in not only databases, but generally any kind of data storage for computer systems, the data is always volatile. There's always a point in time, a snapshot, that the data has a certain value. So in this case, if Ferry and Bert will play the game for the first time, their scores are 10 and 20. What if Ferry logs in again, replays another game, and improves his score? So what happens to this data set when Ferry plays again? Now, the first thing, of course, is that when you log into the Pac-Man game again, that the software should be able to find Ferry as an existing player. Therefore, the name attribute will be used to find Ferry as a player that he already knows. From that moment on, Ferry is recognized as an existing player, and it will also read the score of 10, which is stored as the highest score that Ferry has achieved. Now, if he plays the game again and he improves the score, then the software will say, okay, instead of 10, now I'm gonna store the new high score for the player Ferry. So what happens in the database is that the value 10 will be overwritten by the newly achieved higher score of, for example, 30. Yeah. Now, of course, this can keep going on. If Ferry plays again and scores 20, then nothing in the dataset will change because 30 is still the highest score. Bad score can change in that regard as well. If Bad logs on again and improves his personal high score, then this dataset will be updated for an increment in Bird score. Now, what you see here is called a structured dataset. Now, let's break that down. Why is this called a structured dataset? Now, first of all, the number of rows here technically represent a unique player. And every single row represents one player with an individual high score at that point in time. Let's add Lisa in here, or Liza, depending on where you come from. And Lisa is a master in Pac-Man, so therefore Lisa has a score of 100 when she plays the first time, right? Now, what you can see here is a data set that is comprised of what it seems like 2 columns and 4 rows, also known as a data grid. Now, this looks like a table. Remember that I said in the first video that data can be put in a table. Well, all of this can be put in a table because I literally can copy and paste this into, for example, a spreadsheet like Excel, and then it will be perfectly fine when it comes to these data items. So let's focus on the term structured data. So why is this structured? Now, the first thing is that we have identified fixed data attributes. For every single row we store here, which we know represents one player, we store 2 different data items, the name and the score. Now, the name and the score are attributes, and data attributes are kinds of data. The name is, of course, a piece of text representing the name of the player, and the score is the highest score of the player achieved up till that point in time, which will of course be updated by the software as soon as the player improves their high score. Otherwise it will remain the same if it's lower. Now, of course, every row has the same formatting. So it starts with a name, then a space, or at least some it seems like an empty field here, and then a numerical value representing the score, 30. Then the second row has the same structure. It's the name first, space, and then a numerical value representing the score of, in this case, Bert. And then the third row as well, Lisa, space, score, 100. And of course this can go on as well. Now, over time this dataset might change based on the players that improve their score, or new players that play the game, which will lead to a new row in the database. And you can even think of adding more columns to this dataset, because maybe you want to store the player's gender as well, which is technically no problem for a computer. You can just add gender here. But then you need to make sure that for every single row you need to specify the gender. So Ferry would be a male, Bert would be a male, and Lisa would be female. Now, this is something you need to determine beforehand, of course. You need to know what data items, data attributes you need to be able to use within the software. For example, in this case, the Pac-Man game. Now, this is a structured data set because every row has the same data items in the same order, in the same format. And the first row has the column names of the kind of data you store, which are called data attributes. This is, in short, what structured data means. That means that there is a relationship between the rows and the columns that represent something in reality. Of course, the columns here represent the different properties or attributes of, in this case, players. And every row represents, in this case, one player with their score and gender. So this is how computer scientists think of data being structured. Now, of course, you can say, well, but what is then unstructured data? Well, let's discuss that in the last part of this video. And why that is more problematic than structured data to store in a database. All right, so... Alright, in the last part of this video we're going to look at unstructured data, which is for this part of the course the least interesting part. That has to do with the fact that we only store structured data in a database. It's not entirely true, but for the sake of simplicity we'll just make that assumption here. So the first thing we're going to do is just use an example of what unstructured data is, and that we actually encounter it on a daily basis, and that will be done when we access the World Wide Web. That might surprise you. The World Wide Web is an example of unstructured data. Some people would call it semi-structured. There is a kind of structure in the data on web pages, but for the sake of simplicity, we won't consider semi-structured now, since it's not important for our course. Let's try to identify why the web pages and the contents on the web pages is considered unstructured data. Also in the light of the first video, where we identify data as, again, text, pictures, audio, video. For the sake of simplicity, let's keep it at that. Okay, let's go back to the whiteboard and let's identify what I mean. So unstructured data as opposed to structured data has no structure, at least no visible and clear structure, as the previous examples where we used rows and columns that have the same format and the same order of data items. Now, the web, maybe you ask yourself here, but how can the web be considered data? Yeah, if you look at the World Wide Web as the collection of websites that people use to access resources, then, and you ask yourself, what is a website or a web page actually? Then you have to come to the conclusion that that is just a collection of different data items as well. For example, if you go to the homepage of a company, you will find things like pictures, buttons, menu options, links, pieces of text, headers, banners, icons, and all these different objects are comprised of, once again, the four main categories: audio, video, images, text. So let's use an example here and let's just sketch a potential homepage of a web page, right? So for example, let's say we have Google, so the word Google here, right? Then there is a search bar here, which is an input box. Here we have a piece of text here called search. And maybe down here we have a picture of Larry Page. Now, of course, that is not the real homepage of Google. Larry Page is not that vain. If you don't know Larry Page, he's one of the inventors, the founders of Google. And here's a picture of his co-founder, and his name is Sergey Brin. Now, of course, this homepage is not reality, but just to give you an idea of what a homepage could look like. Now, if you look at this from a data perspective, you can see that, and you identify that in the 4 categories that I just talked about: audio, video, pictures, and text. Then you can see we have the word Google on top in the middle. We have the word search here. We have a graphic element. Technically, you can say a picture, because it's just a shape, a rectangle representing an input box to search. Then we have 2 pictures of the founders, and maybe here we have a button that says search. Now, all these items are data. Can you put them in a list? Yes, you can. You can make a bullet point list and put every single object in this design in a list. Now, why is this considered unstructured? Now, every single homepage has a different set of objects. In this case, we have pictures and text, buttons, maybe videos and links present at a certain place on the homepage. Another website has different pictures, different pieces of text, longer text, different format text in their own homepage, or maybe a subpage. Different colors, different font and font sizes, different layout. So if you would consider the World Wide Web as the collection of web pages a data set, then that data set is unstructured. There's no one format, no one page, no one website that always follows the same layout, just like we did with the rows and the columns in our grid in the previous examples. That was structured data. So because this is so, we can say almost chaotic, so unpredictable, we don't know what pictures, what text, and what links can be found on a website, because every website is unique in that regard. It makes it also harder to search and store the data that we are looking for. Now, of course, you can browse the World Wide Web by using the Google search engine or another engine. And what you technically do is then you browse an unstructured data set looking for pictures like Google image search, or videos, or news items, or news feeds, or all these different kinds of content, which is in itself data itself. Because the data is of so varied, of a different kind, it makes it harder to find a way to structure it, to navigate it, you can say. Now, of course, I gave 2 opposite extremes here. So the Pac-Man game with name and score as the main data items versus the World Wide Web as a large data set with unstructured data that can technically contain any kind of data in any order that you want. You can design a web page the way you want. That's the opposite extreme. So what we're going to do is we're going to focus on structured data. Now, that doesn't mean that structured data will be simple, because how many columns and rows can a grid actually has? How many data items can you identify? For example, how much does the bank actually know of you? The bank database, how many data attributes does the bank know of you? I mean, you can start to make a list, right? First name, surname, address, account number, balance, every single transaction that you ever made at a certain point in time, timestamps, account numbers that you have sent money to or received money from, etc., etc., etc. All those data items need to be stored in a database in a structured way. So this is the world we're going to explore. In the next video, we're going to focus on identifying, using a working example, which data items are very common and how they can be stored in a structured manner, so software can easily access it and can also update the data, because that is the main case for any application. I hope you have seen that now, is that software does 2 major things with data: read and write, just like in the Pac-Man example. So we're going to explore that a little bit more in the next video. I hope this was clear. Structured versus unstructured data. For databases, we focus on structured data. Okay, thank you for watching. I will see you guys in the next video, which will be up in probably 2 days. This was Ferry, and SaxSQL out. Please check out my other videos as well in this series if you haven't seen them. They will probably be there, as all these YouTubers do, right? And I will see you in the next one. Have a good one.
Thanks for watching. Check my other videos to master your data.